All right, so the second part of your notes are going to talk about the different types of roots. So, unless otherwise stated, it's assumed a radical is a square root, which means that the factor is 2. So, you need pairs of 2 to pull it out of the square root. Square root is a number multiplied by itself to get a perfect square. So, those two factors have to be the same, like 8 times 8. So, the square root of 64 is 8 because you have a pair of 2's. There are other roots, like a cube root, that means the factor is 3. So I have to have 3 of that number to pull it out of the cube root. Or fourth roots, because there have to be 4 of the same factor to pull that out of the fourth root. So that's what we're going to talk about, a few of those. All right, so here's an example of a cube root. Okay, so that has a 3 there. It's called a cube root. Index, which is this here, that tells us um, that's how many we need in order to pull it out of the radical. Okay, so if we have the cube root is 54, if we factor out 54 like this, okay, do a factor tree, we need 3 of them to pull it out of the radicand. So we have 1, 2, 3. So we can pull those 3 out. Okay, and then what do we have left over? We have 2 left over, but it's not inside of a square root, it's inside of a cube root. So you have to make sure you write that down. Okay, so let's go ahead and try this one. So we're going to factor out 8. So 2 times 4, and then 2 times 2. So this is a cube root, which means we don't need pairs, we need a set of 3. Well, luckily we do have a set of 3. So the cube root of 8 is 2. Nothing's left over. Okay, let's do 81. So we have 9 times 9. Now, if this was a square root, we could stop because we have a pair of 9's. But we're not looking for a square root, we're looking for a cube root. So we need to continue to factor that out. So we're looking for 3 of them to pull it out of the radical. So we have 1, 2, 3. So we're going to pull that 3 out. Do we have anything left over? We do. We have still a 3 left in the cube root. So the cube root has a 3. So my answer is 3, cube root of 3. Okay. This is called a fourth root. So we need to factor it out. 9 times 9. Can't stop because we're not doing a square root. We're doing a fourth root. So we need to continue to factor. So how many do we need to pull that out of the radicand? We need 4. 1, 2, 3, 4. Well, we do actually have a set of 4. Is there anything left over? No. So that's our answer. Okay, let's try this one. 80. So 8 and 10. That's 4 and 2. 2 and 2. 2 and 5. So we're looking for a fourth root. So instead of 3, this time we need to have 4 of something to pull it out. 1, 2, 3, 4, so that we can pull the 2 out. Do we have anything left in the fourth root? Yes, we have in the fourth root, we still have 5. So there's our answer. Okay. All right, next one, 48. So we're going to do 6 times 8, 3 and 2. That'll be 4 and 2, 2 and 2. Okay, we factored it out, and this is a third root, so we need 3 of them to pull it out of the radicand. So we have 1, 2, 3. That can pull out. Look, we have a coefficient already. So what do we do with the number? We multiply those two. So 2 times 4 is 8. What do we still have inside the cube root? Well, we have these two numbers. So what is 3 times 2? 6 is still inside the radicand. Okay, let's try the next one. We're going to go ahead and factor out 48, 6 times 8. Did I just do the same one? Yes, I did. Sorry. Okay, let's do this one. 24, that's 4 times 6. We're looking for a cube root, so we need 3 of them. That's 2 and 2. That's 2 and 3. So we need how many? We need 3 to pull it out of the radicand. There's a set of 3, so we can pull the 2 out. We do the, what with the coefficient? Multiply, so 2 times 2 is 4. What do we have left over in the cube root? Well, we have a 3 left over, so we need to leave it in the cube root. and that's it.